G'day and welcome to another Space Engineers tutorial. Today we're going to be taking a look at power systems. The reason we're going to take a look at power systems is because our little mining ship is starting to run low. If we take off and hover, you'll see that while we're pushing up, we've only got 19 minutes. And when we were coming back with all that ore before, we were running a bit low as well. The other reason we need to start looking at power systems is because if we are trying to operate both our basic assembler and our basic refinery, their maximum power required, 330 plus 280, is more than the single wind turbine can put out. That means if I'm operating both of those and the ship is connected to the base will start stealing power from the battery, and we can demonstrate that now. If I go into my control panel and look at the battery, currently it says fully recharged in 1 day. It is getting a very slow trickle of power because our wind turbine, producing 394, is producing an extra 60 kilowatts beyond what's required for the basic refinery. If I then go to production and say, I want another 10 steel plates, and then look at our battery, you'll see that it's now being depleted rather quickly. That's not ideal, because then we won't be able to use our ship for discovering other things around and doing all of our mining instead of doing it by hand. So, we've got a couple of options available to us. If we go to our G menu, you can see what we've got in our power options. We've got batteries, we've got solar panels, we've got hydrogen engines, and we've got wind turbines. Right now, we've got very little ice, so hydrogen engine is out. Batteries don't actually produce power except for when they're initially built, giving that 25%. So really, to produce more power, we've got solar panels and we've got wind turbines. If you're in space and you've gotten further through the game, you will also have access to reactors, which require uranium to run. These produce a lot of power, are very efficient, and with uranium, you can basically run your whole base off these without needing to consider anything else. You will need to be in space in order to be able to do that though, since uranium is now only available in asteroids. You will not find it on any of the vanilla planets. So, are we going to build a wind turbine or are we going to build a solar panel? Let's take a look at some of the differences between the two of them. If we have a look over here in our G menu, you'll see that there are these two icons. The one on the left means that the block is available for small grid, and the one on the right means the block is available for large grid. If we have a look at our wind turbine, it is only available for large grid. And there's more to it than that. Wind turbines will only work if they are on a fixed grid. If we have a look at our blocks from the bottom of our station here, they are embedded in the voxel. When I placed them, I deliberately made it partially intersect so that this was a locked grid. This is considered a station. If I had have placed it up here and let it fall to the ground, it would have been loose and the game would have considered it a mobile grid. For wind turbines, you must be on a static grid. You cannot be on a mobile one. You have to lock it to the voxels through some method. The most common of these being starting your base with one of the blocks half embedded in the voxels. If we look at our solar panels though, they're available for both sizes of grid, and they'll work no matter whether they're on a mobile grid or not. This can be handy so that when you get more advanced, you can build solar tracking systems where the panels will follow the sun as it moves around. So if wind turbines are so inflexible, why did I choose it to begin with? Well, they have a couple of advantages. We go to our control panel, we'll turn off our basic assembler temporarily. The reason for that is I'm going to queue up what's needed for each of these blocks to compare the resource requirements for them. I've queued up the bare minimum components required to build a working turbine, and it needs 165 iron, 13.33 nickel, and 0.13 silicon, which isn't that bad. Now let's have a look at what we need to create a large grid solar panel. So for a large grid solar panel, we need 79 iron, which is less, that's nice, but we need a lot more silicon and a fair bit more nickel as well. And if you're refining rock to get all of your resources, this is going to need a lot more stone to be produced, because you get mostly iron from your stone and you don't get that much silicon. So you'll need to mine more stone to produce these solar panels. If they're all that's available to you, then they're all that's available, so you'll use them. But because we've got wind power available to us, that's what we're going to go with. On top of the additional cost of solar panels produce substantially less power. I've added a solar panel to this tower to demonstrate how much less power they produce. Our sun is virtually directly overhead, so this is getting the maximum power it's ever going to produce. And you can see that it's at maximum power because these 4 lights are lit up. Those status lights on the solar panel will tell you how much power it's receiving at any particular time. In our control panel, you can see that the solar panel is producing 159 kilowatts. Comparing that to our wind turbine, which is producing more than twice as much and costs less stone to make the ingots for, I think you can see why I would recommend, if you can, to go with wind turbines first. The last thing I want to mention is that you don't want to block the amount of sunlight getting to your solar panels. If you have any obstructions, it will reduce the amount of power these can produce. Similarly though, wind turbines can be less effective if you obstruct them as well. If I were to build a bunch of light armor blocks like this and obstruct my wind turbine, it will produce less power. As you can see here, it's 338, but without those blocks, it was 394, I think. So we don't want to do that. We want to keep it clear. The sort of distance you want to keep clear from these turbines is about 20 meters. So, since these are 2.5 meters per side, let's move 8 blocks away. 1, 2, 3, 4, 5, 6, 7, 8. And then we'll go up here and build our second wind turbine. As I mentioned in the first video in this series, the height above the voxel material also makes an impact on how much power you can produce. With that second wind turbine, you can see that our batteries are recharging much faster. Previously, this said recharged in 1 day, which is a long time to wait to recharge your mining ship to just go out and use it up in 15 minutes. It's now down to 3 hours, which is still not great, but it's a lot better. The information that's provided here is quite important and gives us some useful insight into how batteries work. Our maximum output is 4 megawatts. That means that each battery can put out that much at any one time, and that's important when you consider how much power draw things like thrusters may have. We'll look at that shortly. Our max required input is 4 megawatts, which means that's the maximum power you can put into this to be able to charge up the battery. There is a ceiling on how fast you can recharge a battery related to this amount. Our max stored power, how much we can actually keep in the battery at any time, is 1 megawatt hour for the larger small grid batteries. Then we can see our current input, which comes from these wind turbines with 50% or a whole turbine going to each battery, and our current output, because the power goes into the battery and then comes out of the battery to go to the rest of the things on the base. The batteries pull the power first. Our stored power, and then how long it's going to take us to recharge or deplete the battery. Just before, I was mentioning the maximum output of batteries. If we disconnect from the base, you can see on the right-hand side of the HUD a little lightning bolt symbol. Currently 13% of our maximum output is being used. If you're designing a small ship, an important test you can do to check that you'll be able to provide enough power to that ship for doing everything you want it to is to boost upwards while also moving to the left and forward at the same time. You can see this is my maximum power output. I'm using up 57 or 58% of my power production. It was going down because I was getting altitude. One reason I mention this is because atmospheric thrusters use a lot of power, so you won't easily be able to provide enough power with things like solar panels directly. With our extra wind turbine, we're managing to recharge our battery on our little ship. But if we fly off, all that extra power is just going to go to waste. An option we've got is to pop another battery onto the base itself. If we have a look at large grid batteries though, they are quite expensive. Even just the power cells alone require a fair amount of resources. We need a lot of nickel, we need a decent amount of silicon, and we need a fair amount of iron. That's more iron than required for each of those turbines. So it can be fairly expensive to set one of these up early. But the advantage of it is, while I'm off using that little ship, my base will accumulate power, which I could then transfer from this battery to the one on our ship. Let's add a battery to the base over here. I'm going to make a little bit of an extension and then pop it down right there. I'm also going to need to take our little mining ship out to grab some more stone since I'm out of nickel. I have very much overloaded my ship. You can see that it is weighing 40,000 kilograms and I cannot really take off. I did some clever twisting and moving to be able to get out of the mining hole, but that was a bit silly because it was a bit risky. If I go to my inventory, I can show you a little tip that a few people shared on the last video, which I didn't know. If we move stone from our cockpit to our personal inventory, while we're in the cockpit, we can throw it out, which is kind of cool. So you don't even have to get out if your cockpit is piped up to your conveyor system. So let's land on our connector. And we should even be able to pick up those pieces of stone and pop them in our refinery as well. And there we go, we have a battery on our base. If we hop into the control panel, you'll see that it's currently dragging 473 kilowatts from those two turbines. The amount of power draw a battery has is relative to either its max output or its max required input. Since they're usually the same, we'll just call it one of them. So it seems like by adding this battery to the base, I have slowed down the charge on the ones on our ship. Except, there's a way to fix that. If we hop into our ship and we go into our control panel, you'll see that we could grab our 2 batteries and we'll know which those are because the grid you are currently accessing through is the one that shows up white. So because I'm in the cockpit of the miner, all of the blocks on the miner will show up white, and all of the connected grids, which in this case is just the station, will show up with a color. The color will be different if you're attached to multiple different grids, each grid having its own color, but the one you are directly accessing will always show up white. So let's select our 2 batteries, and let's change their charge mode to recharge. We then look at our batteries, you'll see that they're fully recharged in 9 minutes. Let's have a look at our base battery though, because it is fully depleted in 7. That's because these 2 batteries are charging off the base battery, and it looks like the base battery will run out before these are fully charged. There's a degree of inefficiency transferring power from one battery to another, but in the case of the inefficiency of time, using another method is just going to be way too slow, so I would usually cop that on the chin and just go with it. Use our base batteries to charge up ships so that we can use them and produce more batteries and more power, and eventually that snowball will well and truly outstrip the inefficiency of the system. One of the big downsides in doing what I've just done is what happens when I disconnect from the base. If I disconnect from the connector, my pod has no power and I will crash. Although it looks like I didn't take any real damage, which is very... No, I took some damage. Or did I? Huh, looks like I got away without any damage on that. Which is very unexpected. But you saw that my thrusters aren't working. That's because now that I'm disconnected from the base, as you can see from my connector, this grid has no power source. Because our batteries are on recharge, they won't put out power for anything. From the game's perspective, they're a power sink. They're not a source of power while they're on recharge mode. So if you don't have a little cradle for your ship to stay on, you may not get as lucky as I did, and you may damage your ship when you disconnect. It's really important to make sure if you're going to use recharge that you turn it onto auto or onto discharge before disconnecting your ship, or something to make your life a little bit safer. We grab a few steel plate and let's put a little ledge there, and then a block, another block, and we create a little platform around our connector. Now when we do that trick again, disconnect, and because of our platform, we stay right where we were, and we can go, oh, that's right. Oh man, I need to turn my batteries on to auto so that I can fly. And you can do that without having caused any damage to anything. Do note, this landing pad will, over time, take damage from those thrusters, so you may need to repair it at times. There are ways to minimize that damage, but we'll get into that later on. Now let's lock it down, and we'll leave our little landing safety pad right there. To demonstrate the next trap you may run into with using recharge systems on batteries, I've turned off these 2 wind turbines, so they're not producing any power. This trap is more commonly run into by people who are going to be using solar power, since at night you'll lose all your power generation, so you'll need to have your batteries level out that power supply. If we check out our battery, you'll see that it's depleted in 52 seconds. Let's see what happens when it is fully depleted. Alright, just 10 seconds to go. Let's have a look from here, because there are a few things that you will see change as this runs out of power. There we go. We've got red light on the battery, we've got red light on our O2H2 generator. Our survival kit is off. That means we can't respawn here, and our connectors both turned off. Our ship is in the state that it was in before, our battery's set to recharge, so it's not got any power source for anything to stay on, and this is all pretty much dead. Yes, with wind turbines you probably wouldn't run into this situation because they'll generate power all the time, so there'll be something producing some amount of power. But this is a situation you may run into using other power sources, and there's a really important thing I wanted to demonstrate with this. Right now, our mining ship is without power. I am going to save, because I'm going to come back to this moment. What we're going to do is we're going to fly 500 meters away. And as we cross that 500 meter threshold, you'll notice something change with our, there we go, with our respawn pod. It now says last known location. That's because the game just deleted our respawn pod. Let's quick load so we get back our little mining ship. Excellent. And with it back, I'm going to talk you through why that just happened. If we press Alt F10, we get our admin screen. We can then select in this drop-down box the trash removal. Space Engineers does some trash removal. It removes blocks, grids, things that are unlikely to be interacted with by the player anytime soon or at all, so that performance can be improved. Typically the stuff that it removes is stuff you wanted to. So if you have a fight in space and there are chunks of armor flying off at 100 meters a second away from you, you are never going to find those again. Space is so big, the chances of you running into those little blocks is minuscule, so the game may as well delete them and stop having to keep track of them. However, if those settings are too aggressive, it can remove stuff you don't want it to. The way this checkbox system works is that anything that is checked is allowed to be removed. So powered grids are not allowed to be removed. This ship, in its current state, is considered an unpowered grid. It doesn't matter that those batteries have some power in storage. Right now, because they're on recharge, this has no power. That's why it got deleted when it was more than 500 meters from the player. So, if you think you're going to be smart and save power on your respawn pod by pressing Y and turning it off, you may find that it disappears. So you have an option. You can either turn off the trash removal by pressing suspend here, or you can just keep all your grids powered all the time. If you're wanting to save power on a grid like this, my recommendation would be, if you're not locked to the ground or to a connector, start up a second hotbar, press G, and add to your hotbar on-off commands for those things that are going to use up decent amounts of power. Ore detectors, antenna, and thrusters tend to be high on that list. So if I turn these two off, you'll see my power goes from 7 days till I run out, or if I've got my dampeners on, 56 minutes to 7 days to 9 days to 10 days with all those blocks off. So this is the safer way of conserving power if you want to. This grid, if I move back 500 meters, will not be deleted because it still has power. Now you might be wondering, why isn't the base deleted? The base should have gone. It doesn't have any power. Well, stations are not allowed to be deleted. Now let's turn our wind turbines back on. So we get power back to our base and our survival kit is working again so that if I die, I have somewhere to respawn. We've had a look at wind turbines and a little bit about how to best set them up. We've had a look at solar panels and we've had a bit of a closer look at batteries. Now it's time to have a look at our last power source that's available to us at this stage, and that is the hydrogen engine. First though, we need some ice, because right now we have a grand total of 71, which is not going to be enough. If we take a look at the Earth from a great distance, you can spot some of the locations where you can find ice on the surface. Because I'm in the savannah, we're going to have to go a long way to spot them. You can see now there are a couple of snow-capped mountains to the north and to the south, and behind this band of clouds down here, there should be an ice lake. Here it is. This is a surface ice deposit, so we could probably collect enough ice from here to last us several lifetimes. But it is an awfully long way away. It's 35 kilometers away. So what are our alternatives if we're such a long distance from any nearby ice? Well, I can hop back to my mining ship, grab my ore detector, ensure that its range is at its maximum, disconnect, and let's go have a hunt for some ice. If you're going to find ice, it should be in one of these ore deposits, like the grey speckled area in front of me that's slowly being covered by the grass that I've got on. Just remember, if you've got your ore detector off, it's not going to work, so you need to turn it back on. I may have just flown past a couple of deposits before I realised I had left that off. And then we can hunt around for some ice underground. And there we go. I was lucky. I didn't even plan that. So we found some ice underground here. Whoops. Let's dig down and collect a little bit of that. If you're going to mine like this, you may find it helpful that there is another artificial horizon on your HUD. It's just to the right of the hotbar. It's pretty basic, but it can be very useful when you can no longer see the one that's in front of you on your HUD. And it is something I often forget to use, and that's magnesium. We don't want that just yet. Oh, there's the ice. They're right on top of each other. In my previous searching for these underground ice deposits, they weren't that easy to find. They should be around though, and it can be nice to have something like this, which is only a few kilometers from base, rather than having to use something that is 30 kilometers from my base. And I have overloaded this, so let's see if that's enough. There we go, that should be alright. We now have a healthy supply of ice. In our O2H2 generator, it is completely full. So, let's try out a hydrogen engine. Let's go onto our G menu, and the hydrogen engine is available for both large and small grid, and at both sizes is fairly expensive. Large grid particularly, and that's the one we're going to be using, since the hydrogen engine for small grid doesn't really have a lot of purpose for us just now. So let's place it down here, directly connected to our O2H2 generator, and start welding the thing up. We've now got our hydrogen engine. It's piped up to something that should be able to provide it hydrogen, but it is not turning on. We are not hearing any sound from it. This fan blade at the end isn't spinning. It doesn't seem to be doing anything at all. That's because it's not. The next few tips I'm going to show you will apply to troubleshooting for any of these sorts of problems in Space Engineers. There are a few things you can do that will often resolve problems you may be facing that are like this. The first is go into the block, try turning it off and on again. Sometimes that will work. Other times, it won't. And sometimes that can be the difference between right now I'm accessing it through the cargo container and before I was accessing it directly on the block. But even now, it's not working. So the toggle on and off isn't working in this case. The next thing to go to is turning the whole grid on and off. Now, before I do that, I'm going to have to build a control seat on this base. I'm going to place a flight seat here, but you could use a cockpit or you could use a control seat. Any of those will work because they'll allow you to press Y to turn the base on and off. You might be wondering why I needed to build this control seat though. Because we've got one in the cockpit of this ship. So I could press Y here, turn off my ship, turn it back on, and then presumably I'd be able to turn the base on, right? Well, no. No, you can't. If we have a look at the base blocks right now, they all show on. If we select them all, turn them off and on again, nothing happens. It's still all red and off. I built this first because I didn't have the resources to build one of these if I got myself stuck in this situation. I would have been properly stuck. I would have needed a reload or to go into creative mode to fix it. But because I've got this seat, I can hop in, I can press Y and I can turn everything on. And now you can see our hydrogen engine is working, as well as being able to reconnect our mining ship. So that power cycling of your base by turning it on and off with Y, or off and on with Y, I should say, can be something that will fix non-functioning blocks like this hydrogen engine. Another method that may work is saving and reloading the game, and in the case of the hydrogen engine at the moment, that was working for me. But let's have a look at the engine now. Right now it is outputting 2.5 megawatts, and if we have a look at our inventory in our O2H2 generator, you'll see that it's using up the ice at a prodigious rate. We have a look at our batteries. Fully recharged in 1 hour. Current input is 650 kilowatts and 1.97 megawatts. We go and grab our hydrogen engine and turn it off. Our battery is now getting just 473 kilowatts. So the hydrogen engine is producing a fair bit of power. And now it's broken again. The joys. Off, on. Ah, it worked this time. See? That troubleshooting sometimes works. Oh boy. It can be a useful way if you've got access to a lot of ice to be able to charge your batteries a bit more quickly from that source. But in our case, I suspect we would burn more energy than the ice we can collect with each trip. Although, maybe. You might get a slight, tiny bit of a positive. You may also be wondering why the hydrogen engine currently is only outputting 2.5 megawatts. That's because the O2H2 generator only produces 50% of the hydrogen the engine wants. You would need 2 generators to output enough hydrogen. 2 generators would require 1 megawatt, and the engine would output 5, so you would have a 4 megawatt bonus in power, while consuming a huge amount of ice. So that's the hydrogen engine. I am not going to use it because I want to save my ice for other things. I'm going to be doing a very detailed breakdown of it soon, but for now, hopefully that's enough for you guys to be able to at least get it functioning and decide whether it's useful for you. And that brings us to the end of our overview of power systems. Hopefully this will improve your understanding of which ones will be most useful for which situations and when you'll want to employ them based on your own desires and which aspects of them you feel are most important. Next time, I'm going to be taking a look at rovers so that we can build our first one and hopefully don't crash it too many times. So there's all that and plenty more to come, and I will see you then.